Okay, this is going to be a video about human vision capabilities because there was a question about this and I had to look it up, so here it is. The light illuminated on a 1 square foot area, 1 foot away from a single candle standard. We used to use really vague things for standards, but not really. The candle standard is a 1 candle power, and the amount of lumens at that distance is 12.57 lumens, sort of. 1 foot candle, which is different, is equal to 10.76 lumens. Now this is getting confusing, so bear with me. The total amount of light released by an object is measured in lumens, but the light illuminated in a 1 square foot area out of that total amount that light can be radiating everywhere evenly at 1 foot away would have a rating of 1 single candle producing 12 lumens on that 1 square foot area. The total amount of energy, however, for a 1 foot candle, which is a different way of measuring it, would be rated at 10 lumens. Lumens is supposed to be the total amount of light coming out, no matter what direction, all of it totaled up. The total energy output of the light source versus how much light you can perceive from one direction. Obviously, if you use lenses or mirrors, you're going to perceive a brighter light, but the candle power doesn't change because it's a candle. Also, it should be pointed out that the candle was based on using a specific type of wax material and a specific type of candle wick that produced a almost perfectly white uniform light source. So that's why it was used. As you might imagine, depending on the light source and the quality of the light, a lumen or a candle power are all going to be very different. Also, color rendering and color tinting will change its perceived brightness. And you can use ultra high quality equipment to measure all of this now and not use a candle as a standard, but human eyes don't work the same way that light sensors or cameras in a computer monitor like this that's stuck in there or on your cell phone work. So we have to use some sort of absolute standard. So this is based on white light being defined as what comes from the sun when you see it through the sky that we experience every day on a completely clear day with no haze. And specific moisture levels and intensity levels and a specific time of year and a time of day on that time of year. Yes, it's that damn precise. And it's the color spectrum, and it is not completely flat. We perceive it as white light. And it is. No, the sun isn't yellow. You don't remember it as being yellow. Please don't post that. How far could you theoretically see in any direction on a perfectly clear day or night with perfect vision? That's also very relative. Without any obstacles, what's the maximum range you can see? Now, the actual question someone brought up was, and this is really silly, but it's not. Can a person with a candle or a cigarette that's lit be seen a specific distance away? And then what's the maximum distance if you didn't have a bunch of shit in the way? And what do we mean by that? Well, here we go. 1.6 miles or 2.5 kilometers, you can see from that distance a candle flame as 1 candle power. That candle. That's maximum distance. Any further away than that, it gets below the level of perception, even in pitch black conditions, and if you accommodate visually. And, I'm not kidding about this last part, a hypothetical version of the world where a completely clear sky, dead at night, and no stars in the sky, with the universe with everything snuffed out somehow. Complete black darkness. 1 candle power at 1.6 miles, or 2.5 kilometers. 5 kilometers, or 3.1 miles, is the limit for a 6-foot-tall approximate average height person with their eye exactly 5-point-something distance above a level C without tidal activity, perfect conditions, which almost never happen over water, if you had 0% humidity. That's an actual specific thing because the humidity affects it. And you'd be able to see that max distance, something at sea level itself, literally floating on the water, maximum distance you can see. It's only 1.6 miles. Obviously, if someone at that end lifted something up even 2 inches, then you could see it much further away. Next, from a fantasy Mount Everest altitude on a island in the sea, you could see a distance the size of Montana, or 211 miles in every direction, or 340 kilometers. That would be because you're so much higher up, you could see much further. So it goes from being 3 miles to 211 by being up that high, because the Mount Everest is 20 some odd thousand feet tall, and that would be an unobstructed view. Please also know that if you were on a tall enough mountain, that the slope of the mountain would eventually meet with whatever maximum diameter you could have for any kind of hypothetical horizon at about 100 miles up or something, but you literally can't go there's a specific distance where you get diminishing returns by being on a taller mountain, to where you're literally at the point where you're higher orbit than when we orbit. But what's the longest distance you can actually see from one point to another, literally, that exists, if the conditions are perfect? This is actually a quest that people go on that are photographers. They'll go onto a mountaintop, line up with another mountain, and wait, sometimes weeks or even years, to get a good photo on a clear day, usually above the cloud layer, and see the peak of another mountain definitively, usually by having a reflector on the other side and hoping that the air quality is good enough that they can do this. Sometimes having to do such a crazy straight shot through some other mountain that's even shorter. What's that longest distance? 334 miles is the longest distance visually confirmed. It could have been done with laser pointers or infrared cameras or something special, but 334 miles, or 538 kilometers, maximum distance. This is a claim I haven't been able to confirm, and I can't get the imaging or even cooperation out of Google Maps because it refuses to let me just type in a GPS location and just put a dot on the map so I can do the lines. But I confirmed that it's actually the right distance. From Dankova Mountain in Kyrgyzstan to Mount Hindu Tai in China. It's a long distance, 334 miles. But that's the longest distance, terrestrial distance, you're able to see on Earth. Period. So if someone says you can see a lit cigarette from 30 miles away or whatever, these are hypothetical, but is a lit cigarette brighter than a candle flame? No, it's not. The longest distance anybody can see anything is a 5.8 magnitude star, just barely brighter than a 6 magnitude. Larger numbers means it's dimmer. And it's the longest distance anybody can see any bright object in the sky under perfect conditions with perfect vision, or my glasses. By the way, my glasses frames have actually broken to the point that I'm going to have to replace them today. But anyway, and it's to see V762 CAS. It's in Cassiopeia. It is a star, and it's 16,308 light years away. It's the longest distance you can see a light source. And it's barely perceivable because at magnitude 6, it's almost impossible to see. The faintest stars a human are able to see unaided on average, with perfect vision. I mean, it's not really average at that point. Have a magnitude of number 6. And this is the brightest and furthest one you can see that can actually be seen. There are others that are technically visible under ideal conditions. Now that is 250 times less bright than the star Vega, which is one of the brightest lights in the sky. Now, a candle at 338 meters away from you, 1,000 feet away, is about as bright as Vega. So, it gives you an idea of how absolutely mind-bashingly dim the light source is. And Vega is actually 2.5 almost magnitudes brighter. A candle is almost 2.5 magnitudes brighter than Vega. But We perceive them as the same brightness because Vega and candles emit light with different spectrums, different light color ratings, and different qualities. That candle is almost a perfect light source, but it's also filtered through the air. Vega is not a perfect light source, and it is not filtered through the air as much, oddly enough. It's just slightly less filtered. But it's a ridiculously long distance away. It's just not as far away as, that one in Casapeo. World War I night snipers regularly shot around 250 meters at matches that were lighting to light cigarettes. Sniper spots the first cigarette, aims on the second cigarette that's being lit with the same match, and fires at the third user. Never light 3 on a match. That's where it came from. At least that's where the scuttlebutt came from. So, where did this come from? Why did I do the video? Well, here's the funny thing. I dare you to find someone who actually measured the lumen or candle power output of a lit cigarette being drawn upon. I couldn't find anybody had it. I found a shit ton of responses from Google searches that brought up how to quit smoking and a lot of specific, very targeted results. But anybody who even bothered comparing the brightness level to a candle so I could see, how far away you'd have to be, it would be less than 1.6 miles at that point, I'm sure, because it's less bright than a candle. Might have been 1 mile, might have been half a mile. Might have been, what was it again? 250 meters, but we'll never know because Google crammed all of the results with advice on how to quit smoking and pictures of lungs that are damaged when I'm trying to find out how bright is the cherry on a cigarette when someone drags on it on average. It's not as bright as a candle. And yeah, it's tilted towards the purple, or not purple, the orange range of the spectrum, so it's going to be harder to see. But you'd think someone would know about it. And oddly enough, nobody teaches this in the military anymore because it was found to be mostly silly. And the fact is that we now use infrared cameras for a lot of things, so they don't have to point at a cigarette. They point at your warmed up barrel if you fired it, or at your face because it's not really covered, because infrared combat. Next, I was asked to look up North Palm Beach County William P. Gwen Airport. It's North Palm Beach County Airport, or William P. Gwen Airport, and some incident that happened in 2004 that's supposed to be related to something. But no matter what I did, I couldn't find it, and I'm still waiting for that. Hopefully I'll get that. I probably won't. But what I found instead, 2018, November 13th, 9 to 10 p.m., Cape Lookout, North Carolina. Not related. Outer Banks, night fisherman, 90-second video. I baited my hooks, cast them out on the surf at 9, walked back to my chair. When I turned back to the ocean, I saw a light in the sky. The light was very bright, stationary, and silent. Over the course of the next hour, it faded in and out, as well as sometimes becoming multiple lights. The lights vanished at one point for nearly 20 minutes, and then reappeared much closer to my position. That's the entire story. People have made a lot of scuttlebutt about that one, but not the one from 2004 for some reason. But anyway, this one, when you look at the images, just like every other time, it's a boat out at the distance, just happened to be pointed that direction, using what are called marker lights. The camera picked up the marker lights. They're just indicating its position so it doesn't get hit by anybody. Not a real debunking. Everybody came to the same conclusion. Or not. You decide. I have a video down below because there's 2 versions of it. Only one of them, the one that's not so popular, actually tells you where the hell it came from. The other one avoids that like the plague, doesn't tell you where to look and see that it's a boat on the water. So anyway, as for the one I'm sure from 2004, it'll turn out to be a real good UFO video, but nobody's been able to show me a photo or a video yet. And I looked, so someone might be doing the same thing of omitting key details that would make it to where I could find out whether or not this even happened or was even talked about. I'm hoping someone gives me a direct link. But anyway, that's it for today. Thanks for watching. Have a good day. Good luck with that.